All right, welcome everyone. This is the brave group that comes to the first session the day after the dbt Coalesce party. So thank you. I think you should give yourselves a little round of applause for making it. All right. Yeah. Hopefully everyone is properly caffeinated and slightly rehydrated at this point. So it's good to see you, and I'm really excited to talk a little bit about context and what Atlan and GitLab are doing to drive the supply of that context. Context seems to be the word of the year. I know we're at the end of the year. It's probably going to be the word of 2026. And I really like it. I think I agree that AI demands context. And this is how we're hearing about it more and more. We're trying to build these chatbots. We're trying to build these internal LLMs. We're trying to build these AI use cases. And the missing ingredient for most of these to be successful at a production scale is context. How do we make sure we're getting relevant responses without hallucination? How do we make sure the data that is underlying some of these models and feeding some of them is of the right quality? There's a new regulation being discussed every single day. Anyone that's part of a global company probably has multiple regional, local, federal, any type of regulation. And it's changing day to day. And so we need auditability of these things. But we also want to innovate. And it's this constant balance of, well, we need to be aware of the uncertainties of AI, but we also need to stay on the bleeding edge to compete in our industry. These aren't really challenging problems, but I don't think they're necessarily new problems. At Atlan, we started as a data team before we were a software company, and we actually built Atlan for ourselves about 8 years ago, when we were doing massive scale data projects. And at the time, we also needed context. And it looked a little like this. These are real messages that we were getting in our Slack channels. Where is this data? How do I get access to it? Who owns that? Where was it built? What does that metric actually mean? Who built that model? Did they leave the company last week? Do they have any documentation? No. The context problem has always existed. And I think it's being driven and sort of resurfaced with this AI wave. But when I work with customers, I try to offer an analogy to how do we actually tackle the context problem. Everyone's talking about it, but how do we actually get the appropriate context for these use cases? And economics is kind of my background, and so I think it is a very simple supply and demand problem. If we think about this as the metadata economy, metadata is really the context that we're talking about, whether that's the technical metadata or the business metadata and the definitions and descriptions. And the demand is coming from these new use cases. So again, supply coming from our systems. This is relatively easy at this point. Most of the modern data stack is actually exposing their metadata in a very ingestible way. The challenging pieces are still those same problems we had in the self-service and the BI era and the original let's democratize data questions. Like, again, what do these things mean? That business context beyond the engineering world has been quite challenging. Demand is coming from different teams, whether it's governance and compliance, whether it's analysts and engineers, and now obviously we're seeing this come from AI systems. So this supply and demand problem is really how I've been framing this as, if you went to Amazon tomorrow and there were no products inside of Amazon, but there were millions of users coming to the platform, it'd be a market failure. If there was millions of products inside of Amazon, but no one to come and utilize them or buy them or purchase them, it's a market failure. And so this is the same thing with metadata. As we come up with new use cases, as teams need more context, we have to meet the supply. And I think what we're finding is we can come up with plenty of demand. There's plenty of AI use cases in our organization. The challenge is now supply. And I think in the self-service era, we could go a bit one by one, maybe learn about a team and a use case, document, hey, take that Confluence doc, let's put it inside of Atlan. But in the AI era, we need to do this at scale, and we need to do this in a way that's much more automated. And so AI is not just impacting demand, but AI is going to be required to supply, to meet the supply of that demand as well. And that's a little bit about what GitLab is going to talk about today. So how does Atlan internalize this? What do we think needs to happen to go from just a traditional data governance, data catalog type platform and really be the context engine in this AI era? We have a unique place in the architecture and in organizations because we're sitting on top and collecting a lot of metadata from systems across your entire data and analytics and AI stack. And when we built Atlan, we fundamentally saw that most of the traditional tools were very siloed, right? You sort of have your data dictionary for your engineers. Maybe the business has a business glossary, but it's not connected to the physical data assets anyhow. So if we change something on our end, on the engineering side, the business has to somehow figure out that we've changed that and reflect it accordingly. And the number one question we get a lot now is every single tool that you're working with has a catalog, some type of catalog. And they're great intra-tool catalogs. But that silo typically is siloed to a particular role, particular team. And so we're missing, again, that context across teams that's required to drive AI. So we wanted to bring this more into an embedded collaborative kind of experience where, hey, your analysts are already in BI tools. Why would we make them log into a separate platform just to understand their data and their dashboards? Let's bring that directly into the dashboard. Let's connect into the Slack channels, into your Jira and ServiceNow and your ticketing systems where all this context about challenges and changes exists. And that's really where context is being spread. And so we wanted to embed into those existing workflows rather than force someone to come into a new platform in and of itself. Traditional data governance is also very rigid. I think there's probably a list of new roles happening or emerging every single day, whether it's data scientist, citizen data scientist, analytics engineer, data engineer, AI context engineer, prompt engineers were a thing for a little bit, and then who knows what the roles will be in the next 3 to 6 months as AI continues to evolve. And so you need a platform that not just pulls in a bunch of metadata and just has it sit there. It needs to be tailored to the experiences that that user needs. An engineer wants to know about the data pipelines, the models, the uptime, maybe more of the data observability pieces. If I'm an analyst or if I'm just a business user, I probably just want to know what my metrics mean and what are the 3 dashboards I know I can trust. Totally different context, totally different use cases, but all of that is really supplied by metadata and high quality metadata. And the last piece is this manual effort. At the end of the day, there's still a human in the loop challenge, and that challenge is we need to get the information out of people's heads and into some type of platform. Good news is some of that, if you're lucky, exists in, like I said, Confluence docs. It exists within Slack channels. That context does exist. We just need a way to harvest it more effectively. And so at Atlan, we've had to embrace, well, context is living in so many different places. We don't know what the technology landscape is going to look like a year, 2 years from now. And so how could we make our platform as open as possible, whether that's giving you the ability to connect to systems and build your own connections outside of the 50 plus that we can do automatically. And last thing, lean into AI and automation. We want to be able to automate workflows across your entire data and analytics estate. Workflow for us is like, I want to apply a tag across 1.5 million assets in one go. How do I do that? Well, we have workflows and workbooks, different rule-based and AI-driven ways to populate that. So going from manual to open and automate is really important. What does this look like in the Atlan platform? We've taken a lot of big bets in terms of really building a solid foundation to support the AI era. I'll start from the bottom. I know this is a really dense graphic, but fundamentally, we are unifying all of the context across your data and analytics and AI ecosystem. So we're connecting to your Snowflake, Databricks, BigQuery, your data warehouses, your data lakes. We're connecting to dbt. We're connecting to your BI tools, your pipeline tools. And all of this is being stored in a metadata lakehouse. It's built on Iceberg. It's open table format. And so you're actually able to access this and use whatever compute that you want. So totally flexible. The layer on top is what I would consider enrichments. This is where, yeah, it's great that we have our schema and our, what we have as column descriptions, but are maybe relatively limited. It could be, I know rev underscore 123 means revenue, but that's not really descriptive to a business user. So we can enrich that with things like, an advanced glossary. We can add the data quality metrics, pull in data quality metrics, and so building out that context here is fundamentally what we're trying to enable in this middle arch. The third piece is where this gets important. Like I said, it'd be completely pointless just to become a holding ground for your metadata. We want to be able to then activate that back into existing workflows. How does a data quality metric or a lineage affect impact analysis? Why do we have to do root cause analysis retroactively? Why not just use the metadata to say, hey, you're about to make a change. You're about to break about 15 people's dashboards. Are you sure you want to make this change? And then we're getting into the AI world even more. Atlan was one of the first, I think, in this space to have an MCP server. And so now a lot of our customers are just interacting with Atlan metadata directly via Claude or different LLMs. And so exposing this type of information has been really helpful to say, maybe Atlan as a UI and user experience isn't what every single persona will need. So whether you're accessing it via chatbot, whether it's completely invisible and just a part of your CI/CD processes, or you want to come and just do data discovery like that Amazon or Google kind of marketplace experience, all of these things are a possibility in this activation tier. And we're really fortunate we've got a lot of recognition for this. We've been recognized as a leader in Forrester Wave, as visionaries in Gartner Magic Quadrants. We're Snowflake's Data Governance Partner of the Year. But I think what's most exciting is we talk a lot about these problems, but the customers that we're working with are the ones that are actually solving these and giving us the best practices that we can then share as the space constantly changes. So we're really lucky to have Sushma from GitLab to talk a little bit about their experience with documenting information and how that can be enabled with AI. So I'll hand it over to Sushma.
Thank you. Thank you, Austin. That was about Atlan. Now let me take you all behind the scenes at GitLab, a company that has been delivering 168 consecutive monthly releases in the last 14 years of relentless innovation, serving over 50 million users worldwide. But what most people don't realize is that behind every single one of these releases is a data team processing 350,000 Snowflake queries every single day, over 4,000 dbt models, and handling 120 terabytes of production data. Amidst all this, we discovered something shocking. Good morning, everyone. I'm Sushma, Staff Technical Program Manager for Data Governance at GitLab. And today, I'm going to show you how we went from having a documentation disaster to achieving 95% coverage in just 4 days. Not 4 months, not 4 weeks, just 4 days. This is a problem that every data team faces, but no one wants to admit. Documentation debt that's killing productivity. But before that, let me show you what GitLab really is. It's the most comprehensive AI-powered enterprise DevOps platform. And the infinity loop that you see is what represents continuous delivery and continuous improvement, empowering the development, security, and operation teams to build the software better and faster. Coming to the data team, it just has one mission: to provide trusted, compliant, and well-governed data to every GitLab employee so that they can make data-driven decisions. We execute this through 4 strategic pillars: data platform and architecture, analytics engineering, data science, and data governance. Let me show you what comprehensive means in terms of tech. We have 64 different data sources at GitLab that feed into Airflow, processed by dbt, loaded into Snowflake, visualized in Tableau, orchestrated for the data quality alerts in Monte Carlo, and we have Claude that's sitting right there, and I'll get to it to tell you why it's most important. And we have Atlan, which is our enterprise data catalog tool. So we integrated all of our metadata into Atlan. The pipes were flowing, the data was moving, with all of the metadata being captured in Atlan. But what we discovered is that integrating the tools is just half the battle. After months, we launched Atlan. We cataloged 1.18 million assets. We had end-to-end lineage, column-level impact analysis, self-service discovery, business glossary. Everything looked perfect. But when we checked our actual documentation, only 6%. Only 72,000 assets of 1.18 million assets had documentation, and as I said, it's just 6%. But here's what hurt the most. Only 35% of dbt models had actual descriptions. And out of these models, the most critical models across all the domains that were driving our key analytics, they had significant documentation gaps, with column descriptions missing for most of them. So this led us to think, how can we do this better? So instead of treating documentation as a manual labor that engineers grudgingly do on Fridays, what if we could leverage our existing infrastructure to automatically generate descriptions, and that too at, just generate descriptions in a massive scale, so that you don't have to do them manually. It's not like you're replacing human insight, but just enhancing it. not disrupting existing workflows, but integrating seamlessly into your existing workflows. Not create generic descriptions, but generate context-aware, meaningful documentation. But even before getting there, I want to show you how this affected our productivity at GitLab. So look at these 4 pain points I'm sure every data team resonates with. Missing column level lineage means that when something breaks at 2 a.m. in the night, we have developers tracing back dependencies through hundreds of models trying to understand the impact, which can take days and weeks. Manual description management means that the documentation just becomes a game of whack-a-mole. You update one model, 3 other models become stale. No single source of truth means that your definitions live in Confluence, handbook pages, Google Sheets, and whatnot. And you ask 3 people what active customer means, and you get 4 different answers. Disconnected workflows means that your development process and your documentation are like strangers passing in the night. And the real impact? When a critical metric breaks, it takes longer hours to fix. New team members take weeks to become productive, and compliance audits become a nightmare. This is where we were. But the biggest cost, trust. When documentation is bad, people stop trusting the data. They build shadow analytics. They make decisions based off of their gut feel. The entire data culture erodes. We calculated that poor documentation was costing us 20% of our team's productivity, and that is 1 full day per week per engineer. So we came up with this creative solution. And here's the architecture. Look at how Claude is sitting right there, taking the metadata from dbt models, processing it, understanding the business context, including the column metadata, the relationships, the compiled SQL, and everything, and auto-generating the documentation and sending it back again to dbt schema files seamlessly. This is our implementation roadmap. 5 steps to transform the documentation debt into automated advantage. First, we extract the metadata from dbt models. This is where most of our information lives. Then we perform intelligent batching because Claude needs bite-sized chunk files to produce quality input. Third is AI description generation, where Claude reads the compiled SQL, the column metadata from the YAML files and generates automated descriptions. The fourth is automated integration, where these automated descriptions flow seamlessly back into dbt schema files. And finally, Atlan reads this context and it provides column level lineage that's fully enriched. Let me show you the actual Python scripts that we used to implement this process in 5 different phases. In the first phase, we wrote Python script to parse the dbt's manifest and catalog JSON files. These files contain the compiled SQL, the column metadata, the relationships, and everything. The key insight here is that your dbt project already contains everything that you need to create good documentation. It's just logged in JSON. This is the snippet, the Python snippet, the code snippet that we used, and it identified 94 product tagged models that were missing descriptions. We can, of course, modify the resource type to generate the required models for the tags to identify which models are missing descriptions. But now 94 models is a lot to handle for Claude. For that reason, we created a batching system. In this batching system, we divided the 94 models into 19 different JSON files with 5 models each for processing, and this is basically to handle the Claude's context limitations. In the third phase, the AI description generation, this is actually where the magic happens. We don't just ask Claude to give generic descriptions, but we give it examples from our best documented models as templates. We provide it with the actual compiled SQL for business logic. We give it custom and column metadata and relationships for context and specific YAML formatting for integration. This is the actual Claude prompt that we used. And look at this output here. It generated description for the field that's called epic weight and dim namespace ID. And the model name is prep epic issue. And see the YAML formatting, it's just perfect. That's because we provided that we need a specific YAML formatting in the Claude prompt itself. And for epic weight also, it understood that that's the column that's used for capacity planning. And the dim namespace ID, it's a pretty common column. You can think of it like, like dim date or dim date ID, where it understood that, okay, this looks like it's a common column, and it went ahead and grabbed the description from our common columns.md file. So that's the beauty of this. Now coming to the automated approach, the descriptions or the automated descriptions that Claude provided now flow seamlessly back into our dbt files. So we have everything that we need. The YAML integrity, it maintains proper indentation, Jinja references, and everything with zero compilation errors, with zero dbt compilation errors. So what would take 30 minutes per model now just happens in seconds. Now let me talk through how this automated documentation enhanced visualization capabilities in Atlan. Atlan already is a very powerful tool that provides you column level lineage. You can clearly see how the columns are connected through your data warehouse at the most granular level. But what we discovered is that a visualization without context is just a technical diagram. Our engineers for sure knew that columns were connected, but they didn't know what those columns meant or like why are they even being used for. For that reason, we created this automated documentation where it now helps the engineers trace back the actual business logic behind every single transformation in the column lineage. So we were able to enrich this column level lineage that you see with business context with the help of the YAML integration that we did, along with the automation and Claude AI. This impact was transformative. The engineers now understood what each column means, see the business logic in the lineage, make informed decisions based on the impact analysis, and could confidently modify pipelines because they knew exactly like which pipelines are going to have a downstream impact. So now we had everything in place. We had automated integration, and the lineage in Atlan was also enriched. But documentation in isolation is worthless. We had to integrate this into our GitLab CI/CD pipeline. Whenever a developer changes a dbt model, our CI/CD pipeline analyzes the impact and it triggers the impact and it shows the developer in the MR itself in the form of comments. It says that, hey, your change is going to impact 20 downstream models and 3 executive dashboards. So now even before the developer hits the merge button, they can actually see the impact that they're going to cause with their change. They can notify the stakeholders and no more broken dashboards in Monday morning stand-up meetings. So this is a GitLab CI/CD integration, and see how the merge request gets permanently linked into the Atlan asset. So now the developers could see potential downstream impacts even before clicking on merge or hitting merge. And our data team or even all of the developers are now preventing data disasters rather than reacting to them. Now for the moment of truth. What did we achieve from this? Our documentation jumped from 35% to 95% for the most of our critical models. And we were able to document these models in less than 4 hours, which would take 7 to 8 days for us to document. And we could prove that our dbt project works for models over 500 plus, and that too with 0 dbt compilation errors. And we could cut down the documentation time by 50%. What that basically means is that now data engineers could spend more time building pipelines rather than spending time on documentation. And here's my favorite stat. Mart product usage model, it's one of our most critical models that feeds our analytics, and it contains 160 plus columns, and previously it used to take days for us to document that model, but now in less than 10 minutes. And that too, the descriptions are so consistent throughout. What this means for our teams? Yes, for data engineers, they are building pipelines rather than spending time on documents. For analytical engineers, they trust their queries. They know exactly what a column means, where it's being used in the downstream dashboards. And for business analysts and functional analysts, no more what does this field mean Slack messages, because they can self-serve through Atlan, because Atlan now provides that context-rich business transformations and like whatnot in the column level lineage itself. And for data scientists, the 160 plus column tables that I was talking about are now searchable, understandable feature stores. We didn't just document our data, we democratized it. From an engineer to an executive, now everyone understood and they trust our data, and that is a real ROI for us. Of course, it wasn't a smooth sailing. There are some lessons that we learned and that I would like to share with you. So instead of boiling the ocean, we would recommend that you start incremental, identify the most critical models, show the value, and then expand. Data quality rules and standards do apply for AI. Garbage in, garbage out, yes, it's for AI. Because your AI is only as good as your underlying data is. And this is not a technical project. You would need organizational buy-in, so you have to show the value. Some of the common pitfalls to avoid are, please do not over-engineer, start small, start incremental, design for performance from day one. And we need to understand that engineers and analysts are different audience, so their documentation needs are going to be different. And coming to change management, it's important to demonstrate value before expanding requirements. We are not stopping here. The finance and the GTM teams are adopting this approach. We are using AI for generating business glossary within Atlan. We are using AI for enhanced monitoring, creating automated data quality alerts. That too with deeper GitLab integration. And the key insight? Successful documentation automation requires equal investment in technology, process, and people. The technology enables it, the process scales it, and people adopt it. I'm going to leave you all at that today. I hope that was helpful, and yeah, just let me know if you have any questions. I'm here around, and you can also feel free to just ping us and just meet us in the Atlan booth. Thank you all for your time. Thanks.